Hello everybody, my name is Jose Luis Luna Sanchez. I study at UPITA IPN. I am going to present this work, 3D printing acrylic nanocomposite for skin regeneration. Along our living, we might be exposed to suffer any accident that might require organ replacement or organ regeneration. Perhaps we haven't heard about the advances that researchers have got in this area. In this slide, we can observe two examples where they use 3D printing to build small prostheses to repair our heart and ear. Maybe the most frequent reparation we have heard about is our dental pieces reparation, where the dentist analyzes our dental pieces and make a plan of reparation, uses a mold to content the resin, cures the resin with UV light, and finishes some details of our teeth. Despite these advances, there is a lot of unsolved questions about the resin formulation, the compatibility of materials, the biocompatibility with the human body, and about adverse reactions that appear in some patients. In this work, we planned to make a composite dispersing silver nanostructures into a photocurable acrylic resin to form a nanoresin, and to use this nanoresin to 3D print a flat structure that could be used to hold or support human cells. The tissue formed could be used to repair damaged organs. The experimental work consisted of, first, round silver nanoparticles were synthesized by a green method, and silver nanowires were synthesized by the polyol method. We can see evidence of its formation in the left images gotten by them, and in the central plot, X-ray spectra. The upper X-ray spectra corresponds to round silver nanoparticles, the red line, and the black X-ray spectra corresponds to silver nanowires. More details about the synthesis and characterization can be found on references 2 and 3. Then we dispersed separately round silver nanoparticles into a photocurable acrylic resin, and we did the same for silver nanowires. We got two sets of nanoresin samples. In the small plots at the right, we can see Fourier transform infrared spectroscopy of the formulated nanoresins compared against the original resin. We can see the chemical groups on the round silver nanoparticle surface are more evident than on the silver nanowire surface. Here, the dark line corresponds to original acrylic resin. The red line corresponds to resin with spherical silver nanoparticles, and the green line corresponds to resin with silver nanowires. We used the photoacoustic method to determine whether there was a variation on the characteristic curing time, tau, among the nanocomposites and the original acrylic resins. We can find details about the photoacoustic method in reference 4. We found that tau changes proportionally to the nanostructure's concentration into the acrylic resin. In both cases, with silver nanoparticles and with silver nanowires, a linear trend can be drawn. It is remarkable that while tau increases about 3.8 times for the nanocompounds with round silver nanoparticles, it increases around 73 times for the nanocompounds with silver nanowires. So the expected characteristic curing time, tau, seems to be longer as the silver nanostructure's concentration increases, and is much more longer if the structures are silver nanowires. In this slide, letter A, we can observe the main parts that conform the printer we used. UV laser is directed with the aid of a galvanometric mirror toward the liquid resin. The UV beam cures small regions of the liquid resin. When the layer is finished, the plate is dipped into the liquid resin. Then it emerges to cure the next layer. Letter B is the algorithm we use to program the procedure in Arduino, and in the right, letter C, we can see the experimental 3D printer. After testing Bicker's hardness, we found that the cured resin with silver nanostructures presented a hardness twice larger than the hardness of the resin without nanostructures. But there is no meaningful difference among the hardness found for even the nanocomposites with round silver nanoparticles or with silver nanowires. In conclusion, it was found evidence to confirm that the nanostructure synthesis process and the nanostructure shape are important influences on the characteristic curing time. Preliminary tests of Bicker's hardness show no meaningful effect due to the nanostructure shape. This research is supported by CONACYT and IPN. We appreciate the analytical support of Matea Group at UPITA, ENCP Microscopy Instrumentation Center, Physics Department at Simvestab, and CETEC Laboratory of Dimensional Metrology and Physical Tests. Part 8 contains the references mentioned along the presentation. Thank you.